Hello, this is 7th module in our video series of GeoWorks, that is Simulated Distillation module. This feature enables the differentiation of various alkanes ranging from carbon 1 to carbon 120, that is C1 to C120, found in oil within a reservoir. It presents both the distribution chart and the simulated distillation curve specific to oil sample under investigation. It is a simple mathematical method based on Antoine's equation curve to simulate physical process of distillation. This process models the phase transitions of an alkane hydrocarbon of C1 to C120 at a single heating rate measured in degrees Celsius per minute. This module also provides details about the oil's composition, including parameters such as average molecular weight, initial and final boiling point. In job management window, we can choose one of the analysis and click on the icon for simulated distillation. Then we can go to compute icon and go to options. We can provide the minimum and alkane, like I want to start from C1 and go to C100 or C120. We can choose like that. So I'll choose the maximum possible 120. Then there are compute options. There are three options for surface segmentation. This segmentation area method is really important. It is the way the FID signal is splitted into sub areas from C1 to C120 and C120 plus, which gives you the proportion of all components and the molecular weight. You have three possibilities. So the trapeze works best for all type of samples. Rectangle, which are actually left rectangle, quite similar with the trapeze method, but will maximize light components, useful sometimes to compensate the underestimation of the SIMDIS RE method on them. And the intercurves, it will take the area between two Antoine's equation curves. It will be the reverse than rectangle. It will overestimate the weight of the heavy components inside the mixture. It can be interesting to use in crude oils. However, in most cases we will use trapezes because it suits all the samples. For the temperature gradient is for choosing the heating rate used inside the Antoine's equation curve formula. It can be theoretical cycle gradient, which is generally 20 degrees Celsius per minute, or can be the real one like 24 degrees Celsius per minute. So it is better to use actual average gradient. And we can smooth the rebuild curve. We can choose how many points to the left and how many points to the right. Then we do the apply dialog parameters. So this is how my graph will be produced. We can go to display and show Antoine curves like this, or can see rebuild curve. We can show hydrocarbon recovered in percentage with respect to boiling temperature, or we can see the hydrocarbon fraction in milligram for C1 to C120. We can also show C120 plus fraction here, and we can see the numerical values also, which includes C value C1, C2 to till C120 and 120 plus, the boiling temperature in degrees Celsius, the cumulative percentage of hydrocarbon, the percent of individual carbon like C38 is 0.92%, and their milligram values. We can move from sample to sample using these arrows. We can take the snapshot and take the photo in Word to make the report, or we can go to file and print to file and produce the results in either PDF or SVG snapshot. For example, here are the results in PDF format. This is all in simulated distillation module. Our next video will contain HTML reporting module.